So the most significant part of the project so far has been our Designapse study, which is a world-leading fMRI study on professional product design engineers. The aim of the study is to explore the regions of the brain that are involved in product design ideation, and we're also looking at whether there are any differences in brain activity between creative design tasks and innovative design tasks.
So we recruited 30 right-handed product design engineers for this fMRI study. So while the designers underwent MRI scanning, we got them to do ideate, manipulate and imagine tasks. And as they do that, they generated 3 distinct concepts per task.
There was several reasons I wanted personally to take part in the study, and I was really intrigued about the idea of where the ideas sparked in the brain, because designers, industrial designers, use both the left and right hand side of the brain. I was also quite intrigued by the study itself, and as we've worked professionally with a number of the Scottish universities, it seemed like quite a good fit between our relationship with research and Scottish universities and my curiosity of how my brain worked.
Interested me in taking part in the study is, first of all, I thought it would be interesting to see what it's like to go through an fMRI machine. Obviously interested to know how the creative brain works. I think it's something that's fascinating. This is something I haven't heard that's been done before, so I think the whole study in itself is just something quite exciting to be a part of.
Creative tasks are very open-ended. So we would give the designers a problem to address, but we wouldn't specify any functional requirements or any aspects of the solution. Whereas in innovative tasks, we would usually specify at least part of the solution to be developed by the designer.
So during the fMRI scan, the participants would first be set up in the scanning environment, so they would be given a pair of goggles, handheld response button, as well as microphone. So during the scanning itself, the participants would have up to 85 seconds for the ideate task, and then 30 seconds for the imagine and manipulate tasks. So as the participants initiated each concept, they would press the response button and do the same thing each time they have a new design concept in their head.
The process itself intrigued me, and working with the team was really interesting as well in the study, because it was the time in the machine, but then also the kind of getting the ideas out afterwards, which was really interesting, because it was 40 minutes or so in the machine, but it took about 4 hours to get the ideas down on paper. So
we also looked at mental imagery. The reason we're interested in comparing design ideation with mental imagery is because although design is a very visual activity, so we think it involves visual mental imagery very, very heavily, it also involves a lot of non-visual information as well, so things like functional requirements, product functions, technical aspects of the product and things like that.
I was asked to specifically resize or reorientate specific parts of a design, such as like a wheel on a tractor or a car, something which is a detail which is on a lot of products, but just to think of it in a large scale or in a different position, orientation that it would normally be in. It's something I often think about without realizing it, but being asked to do it specifically was something which I've never actually been asked to do before.
So in previous MRI studies of visual creativity and visual design, what the researchers have found consistently is the engagement of the right prefrontal cortex, including the right and inferior frontal gyri, the right precentral gyrus, as well as the thalamocortical nucleus, and the left midfrontal gyrus. So in this study, it might be expected that we'll find similar activations in these cortical regions.
So after the designers had completed all of the tasks and we took them out of the MRI scanner, we asked them to create rough sketches of all the concepts they generated during the ideation tasks. And we then used these sketches as a basis to evaluate the novelty of their ideas. And this then gives us a measure of their design ideation performance. So the more novel their concepts are, the better they performed. And we can then use this measure in the analysis of our fMRI data to help sort of strengthen our understanding of the brain regions that are associated with product design.
I think sometimes the product designers and all kind of creative people are sometimes limited by their ability to get things out of their head into the 3D world, into the real world. So, from paper and pencils to CAD systems to more advanced CAD systems, we're still filtered by the tools. So if we can get from the idea to the tangible to something that's kind of in the real world, surely we can get to a better result, something more creative, more innovative, bigger leaps forward.
Well, although neuroscientists haven't historically shown much of an interest in creative thinking, the importance of creativity across a whole range of different fields is really starting to be recognised. So there are an increasing number of fMRI studies in this area, but none of them look at creative professionals, or product design engineers in particular. So investigating the neural basis of creative tasks like ideation in professionally trained designers won't only help to increase our scientific understanding of design, but it will also help to sort of broaden and deepen our understanding of human creativity generally.